Hi, welcome back to another episode of Algebra in Words, the video series for YouTube. In this episode, we're continuing our discussion of the exponent rules of variables. Specifically in this episode, we're going to be going over what you do when you take a power to a power and also distributing an exponent throughout a group. So anyway, let's get started. And before we start, if you would prefer to follow along and read along with the topic we're going to go over today, you can find that on page 41 of my book, Algebra in Words, which you can find on Amazon, and the link to that is in the description box below. So let's get started. I have 4 problems on the board here, and they're all of different difficulty, and they're all to exhibit a few different details. So let's start with an easy one on the left. We have, in parentheses, x squared raised to the power of 5. This is what you would call a power to a power. Now, the thing that you want to learn at the very start of this is that when you think of power to a power, you think of doing exponents, right? But when you're taking a power to a power, instead of doing the exponent, you're going to multiply the numbers. So for example, this is going to be 2 times 5, which is going to be x to the power of 10. Before we move on, the point that I'm trying to make, the habit that you want to make sure that you break early on, is this is not going to be like 2 raised to the power of 5, which would be 32. It's not that. That would be if you had 2, the normal number 2, raised to the power of 5. But a power to a power, you multiply the exponents. So make sure that you remember that going forward. Let's look at the next one. Now, also, as we could have said with this, a good way to learn this in the beginning is when you have a power to a power, usually, I don't know of many examples when it's not like this, you have a power outside of a group. So in this one, we distributed the outer exponent to every exponent of every variable inside. In the first example, there was only one variable to the power of 2. But in the next one, we have 2 variables, x cubed and y to the unwritten power of 1. So in that case, the first thing that you want to think of is distributing the exponent of 5 to each of the exponents of the variables inside. And I'm going to write those steps out. So it's going to look like 3 times 5, and then y to the 1 times 5. And now we're just going to complete this by multiplying the exponents. 3 times 5 is 15. That's going to make x to the power of 15. And 1 times 5 is 5, making y to the 5th. So that's all there is to that. To summarize that, distribute the exponent and multiply the exponent. Let's look at the next one. And the next problem I chose because there's actually 3 variables plus a coefficient in front. And once again, I probably didn't leave enough room here, but that's all right, I'll do it below. The first step is to distribute the exponent to every factor, including the number 3. So what it's going to look like at first is base 3 to the power of 3. All right, and I'm not going to write them like I did in the last one. We're just going to automatically do the multiplication. 3 times 3 of the power of a is going to be a to the 9. 3 times the 2 exponent of base b is going to be b to the power of 6, because 3 times 2 is 6. And then 3 times the unwritten power of 1 of c is going to be 3 times 1 is 3. This answer is acceptable. 3 cubed, a to the 9th, b to the 6th, and c cubed. But if you or your teacher prefer that you expand a number raised to a power, then that's fine. You could also write this as 27 a to the 9th, b to the 6th, c cubed. And finally, let's look at the last problem. This problem is chosen because there's a fraction inside the group, and it is raised to the power. What you want to remember is you can have a fraction inside the parentheses, but you must remember that the exponent must be distributed to every factor, not only in the numerator, but also to every factor in the denominator. So I'm just going to write that out so we can see what it looks like in the intermediate steps. 5 squared, and then x to the 3 times 2, this 3 and this 2, over 7 to the power of 2, and then y to the 4 times 2. And we're almost done. Let's just wrap this up by multiplying wherever we can in the exponents. So 5 squared, you can leave that 5 squared if you want. You can also expand that, which we'll do in a second. And then the x is going to be 3 times 2, which is x to the 6th. Then in the denominator, we can leave 7 squared in exponential form, and then y to the 4 times 2, or y to the 8th. Now, just like we did in this problem, you can expand a number raised to a variable. So 5 squared, you could write 25 x to the 6th, and 7 squared you could expand as 49 and y to the 8th. So that's it, just 4 problems in this episode. This is a little crash course on taking a power to a power, also reminding you to distribute the exponent through to every exponent and every factor inside the parentheses, including if you have a fraction, reminding you to distribute the exponent to every factor in the numerator and the denominator. So that concludes this little crash course on taking a power to a power. If you found this video helpful, please like, please give a thumbs up, please share with your friends. I appreciate any feedback in the comment section, and also please check out my other videos on Facebook and Instagram. In the next video, we're going to be looking at what to do when you have a negative exponent, and then the video after that, we're going to take all the exponent rules and mix them together and look how to simplify problems with the mixed exponent rules. So thanks for watching. See you in the next video.